Hello nature lovers! Today we're going to talk about nutrient cycles. It may take 2 videos to get through this. We'll see where we are. I don't know how long it'll take. The first thing to understand about nutrient cycles is that it is a cycle, and we're going to compare that to energy. So energy is more of a linear system, and whereas nutrients that go through the ecosystem are more of a cycle. So let's talk about what that means. All right, so if we look here, let's start with solar energy. Solar energy comes from the sun, and we realize that it's converted to chemical energy by primary producers, by photosynthesis, right? And then that energy, that glucose that's made by producers, is used by producers via cellular respiration, turns it to ATP, and that ATP is used to do all the body processes, okay? But the glucose is still kind of the storage unit for energy, and when a rabbit is eaten by a primary consumer, let's say a fox, that rabbit passes on its energy in the form of glucose to the fox. And then if the fox is eaten by, I don't know, a coyote, and the coyote, then it gets the glucose from it. And then let's say it goes up and it's eaten by a Tyrannosaurus Rex, just because I don't know what else would eat a coyote at that point. So its glucose that started with the rabbits passed all the way up here. When it needs energy, the glucose is changed to ATP via cellular respiration. We learned that the other day. And it goes all the way up here until we get to decomposers. Our earthworms, our bacteria, our fungus, or even our vultures. Those kind of things are all decomposers. And they break down the food that's glucose, and they use the energy just like everything else by having cellular respiration in their mitochondria, and that breaks down that glucose into ATP and does all their body functions. Now, most of this energy is lost, as we remember, as heat. Okay? So, when primary producers are eaten, most of the energy doesn't go to the next level because it's lost as heat. Primary consumers are eaten, most of it's lost as heat. Secondary consumers eaten, most of it's lost as heat. And tertiary consumers decompose, guess what? Lost as heat. That's exactly right. And then what's easy to remember here, or maybe not easy, is that this is a linear system. It only goes one way, okay? There's not any kind of choice. It's just, it starts here with the sun, and it goes all the way to decomposers, and that energy. And yeah, sure, decomposers can happen here or here or here. All that's true, but the energy flow only goes one direction. There's no energy going back. It doesn't cycle back around, and primary producers get energy from the decomposers. It doesn't work like that. So this is our energy system, and it's a linear system. It only goes one way. Okay, by comparison, we have how matter cycles. And matter does cycle. It's very much a kind of a circular type deal here. So we're looking at energy versus matter. We just looked at energy. Now we're looking at matter. Okay? So here's the things to realize. I know this is small, but there's a lot of information. Matter, like energy, is not created or destroyed. It's only transformed. And what transforms it? Biogeochemical cycles. How's that for a Scrabble word? Biogeochemical cycles. And bio is for biology, geos for earth, and chemicals for the chemical physical cycles. And we'll talk about that in more detail in just a moment. But here's why they're important. The earth doesn't get new matter from space like it does energy. So the earth is constantly getting energy from the sun that replenishes everything. That's how come the linear system can keep going, is because the sun replenishes it. But there might be a little bit of new matter that comes from space in the meteors or something like that, but very, very little compared to how much is used. So we have to reuse that matter. Okay, the biogeochemical cycles are powered by the energy from this linear system, this solar energy system we just talked about. Yay! All right, so the reason that all that energy cycle is important is that's what does these biogeochemical cycles. For the biology part, all that ATP we talked about, cellular respiration, that's what does these biological processes. Now, what are these biological processes? Well, they include any and all processes performed by living things. Examples include eating and it also includes breathing, and then burning this food in the gut, and then eliminating the waste via urinating or perspiring or uh, pooping. Anyway, I won't show you a picture of that. So anyway, eating, breathing, burning food, eliminating waste, those are biological processes. They all take energy. ATP is what provides that energy. And this is a major way we cycle nutrients. And we'll talk about that when we talk about specific nutrients. Okay, given that, then we go into geological processes. And they include things like volcanic eruptions. Okay, look at all that carbon dioxide right there, as well as methane, as well as potassium and so forth. It's all just shooting up there. Okay, another way is the rock cycle. You know, the sedimentary rock traps, things like little tiny clams and so forth in the rock, and that carbon that it's locked up in the shell of the clam, that calcium that's locked up in the shell of the clam is trapped in the rock, becomes part of the sedimentary rock. It's a pretty common thing. The tectonic plates on the ocean floor, where the vents are that let out energy here, or as the plates spread and new material comes up from the bottom, that kind of helps cycle some of this too. So you got volcanoes, you've got the movement of matter via plate tectonics, you've got the rock cycle, all of that stuff helps move these cycles along. Okay, so then we go to chemical and physical processes. Formation of clouds and precipitation, that's a big one. You've got your rain, you've got your clouds up here. That moves water around. That's a big one we talk about. It and has a big effect on things. Flow of water moves water obviously around for the water cycle, but it also carries things like carbon dioxide and oxygen, and carries rocks and helps contribute to the rock cycle. So these are all related. Lightning. You might go, what's lightning do? Lightning is actually one way that nitrogen becomes usable to animals and bacteria and plants. Is lightning actually transforms the shape of the nitrogen. And so it's a pretty dynamic process that happens there, and lightning plays a big role. Okay, the last one is human activity, and this is kind of the new addition to the whole thing. And, of course, for millions of years, human activity had no real impact, and really even up to 150 years ago, maybe not much impact, no more than any other animal. But all of a sudden, things started to change. Industrial Revolution came along. And now we've started mining, and we get better and bigger equipment that does huge mining, changes mountains, unearths all sorts of nutrients that have been buried for millions of years. Might be fossil fuels, might be gold, might be nitrogen that's locked up in some form down here in this rock, and these guys break all that up. You have the burning of fossil fuels, of course, your power plants, your cars, all that produces all the energy that we need to live, and all that kind of transforms carbon in the carbon cycle, lets it back into the air as carbon dioxide. You also have kind of clearing of the land, deforestation, either by burning it, which is what's going on right there. That burning it releases carbon dioxide to the air that's trapped in the trees. Even when you mow down a series of trees with this bulldozer, two things happen. One is these things start to rot, carbon dioxide is released. But more importantly, when there's fewer trees, less carbon dioxide is, and the fancy word is sequestered. But that carbon dioxide leaves the air and goes into trees normally. No trees, less carbon dioxide is cycled through. So that's a big part of a problem here. Now, trees are not the number one source of photosynthesis or carbon movement in the carbon cycle. That's probably more in the realm of the algae or some of the I just blanked on it, phytoplankton in the ocean that do more photosynthesis than the trees do, but the trees do an awful lot. So that's a big player in this. Okay, and then of course the final one is like fertilizers. We add things like nitrogen, and we add phosphorus, and we add potassium to the soil to try and grow our stuff. So we actually contribute to the cycle that way by adding. We take it from somewhere else, change it to a fertilizer we want, and then we add it to our soil. And these are the big players in nutrient cycles. This is what moves nutrient cycles along. Okay. in the next couple minutes, I'm going to show you about the water cycle, which I know you know, but I want to use it as our kind of demonstration model. And then I'll make a separate video to talk specifically about carbon and nitrogen, which are the two big things that you may not be familiar with, but that I think are important to understand ecosystems and that IB needs you to know. So let's talk about water cycle. So on the water cycle, let's start with kind of a diagram here. Here's sort of, I don't know if you can see it very well. Try and make it bigger. How about that? Okay. Here's kind of our landscape, right? Our sun, our clouds. Here's some evaporation going on. We'll talk about that. Here's rain going here. Here's rivers of lakes. Here's some side view of a lake that's sort of underground. Doesn't show runoff very well. I guess right here, this kind of light part, it's going to show us the groundwater. But let's see what we can see here. All right. So, you know, it's kind of, it doesn't matter where you start in the cycle. That's the whole point of a cycle, is that the whole thing gets there again, right? But I think what I want to show you is we're just going to start with precipitation. Okay, so here's precipitation. So what is it? Well, it's when tiny droplets, and we're right here. They're in these clouds, and they have basically what they've done is they've kind of cooled off, and they've started to make little drops, and these little drops start to join in together, and the drops get bigger and bigger, and eventually they get so big that they're too heavy to float in the air. So gravity pulls them down to the earth. And how's it pull them down? Well, lots of ways. It pulls them down as rain, which we already saw. Well, I don't know if I can make this go a different way. Let's try moving this over, right? So we got rain. We've got snow. Wow, that's stupid. Okay. Snow, sleet, hail. All of these things are forms of precipitation. Okay? And so that's how the water kind of gets to the surface of the earth. And that's step one. So let's start with precipitation. Again, step one is just a convenience. Any of these that I show you today could be those steps, okay? All right. Let's see if I can make that just a wee bit smaller. There we go. So we got a little room. All right. Let's take precipitation away. Next step is runoff. Okay? So as this rain or snow or sleet or hail hits this mountain or any kind of surface, it either goes down through the water, or the ground, which we'll talk about in a minute, or it collects on top. And then when it collects on top, ultimately, it's going back here to the ocean. But it may be in a river for a while, okay? Or it may be in a lake, or a pond, or a puddle, or any of those kind of things. Or it can be trapped up here on top of the mountain as snow. So a nice big snow cap, okay? Well, when it does that, anytime that water's on the surface, we call it runoff. Okay, so it can be any of those things. So that's kind of step two. Now, some of that, instead of staying on top of the surface, it goes under the surface. It percolates down to kind of this level, and it makes a great big lake underground, which we call an aquifer. There's the word right there. An aquifer is just an underground lake, and it's not exactly like Table Rock Lake floating underwater. It's basically more like holes in the rock. If you think the rock is having lots of air spaces that fill up with water, that's what it's like, okay? Now, what it does, it percolates, it kind of goes to the ground, which helps filter it out, clean it out, where it meets with the ocean. Eventually, you see how this kind of gets down here to the ocean and comes out? Or it's stored in aquifers until maybe the aquifer gets so full that it's even here with the lake. Or if it comes out the side of the mountain, bloop, it might become a spring. And that's what a spring is when the aquifer is above the ground below it, and it pops out, and that spring joins with the other springs. It becomes a creek, and the creek becomes rivers, and all the way until it hits the ocean here. Okay, and that's kind of how it all goes. All right, so that's groundwater. Again, the water's kind of moving around. You know, and the one thing to mention that I forgot about that runoff part, you know, glaciers and snowpack, that's water kind of trapped in one phase of this cycle. Eventually, that stuff's going to melt. And when it melts, global warming or other things, it's going to go back into the water cycle. But for right now, it's kind of on the sideline of the cycle. It's trapped for a moment in a certain stage. Okay? Okay, let's move. So what happens now? We've got all this water here or in the lake or in a puddle. Well, that water is water vapor, which is a gas. And, or I'm sorry, I'm lying. I'm making that up. That water is a liquid form. Okay? Well, as the sun heats this up, it gives it energy. It gives all those water molecules energy, and they start to vibrate like this. And as those water vapors start, or as those water atoms start to vibrate, they get enough energy, they break free of the surface of the water, and they start to go up in the air. And they float up here towards the clouds, so you get these great big cool clouds made like that. And then what happens to it condenses, and I'll show you condense in just a second. But the warm air rises until the temperature gets too cold, and then it kind of stops and starts to condense. Now what's condensation? Here it is. Condensation is when the water vapor cools, condensing into tiny liquid water droplets, which we call a cloud. Okay? The more of them, the more blocks light, the darker they look. So a dark cloud has a lot of water vapor in it, not much room. Might have some ice up there too. Sometimes those water molecules or droplets freeze and become ice up at that height. Now, basically, as this moves inland, these clouds sort of get pushed up by the mountains or whatever the surface is until they get to a point where those droplets get big and then it rains again, the precipitation we talked about. So those are the basic steps of the water cycle, but we're not quite done. Those are the physical processes of the water cycle. You have precipitation, you have runoff, you have groundwater, you have evaporation, and you have condensation. Those are the five physical, is that right? 1, 2, 3, 4, 5 physical steps of the water cycle. But you also have some biological steps. Huh? Well, let me tell you. So what I mean by that is things need water that live. We have trees, we have animals, we have all that. They drink water. Don't they play a part in this? And they absolutely do. So let's start with humans, because that's what you guys are used to. So you take animals or humans, we drink water, and we release that water. And there's a couple ways. Of course, we urinate, and we perspire, and those release water back to the water cycle. But the real big way is respiration, meaning we breathe. When we breathe out, we always release water vapor over and over. You don't believe me? Go to a cold window, breathe against the window. You'll see the water in your breath condense on the window because it's cold and it loses energy, so it turns back to liquid form. You'll see that. Well, all animals respire. They all breathe, and so they all let out water. Where does that water come from? It comes from cellular respiration. If you remember, that was one of our byproducts of cellular respiration. Okay, that's respiration. The other one happens more in plants, and it's real similar. It's really the same process, right? It's plants releasing water vapor to the air, which is the water vapor is a result of cellular respiration, and then it'll eventually condense in clouds and so forth too. It kind of joins the whole masses there of water molecules, but it's called transpiration, and it's let out of the leaves, and specifically there's a place in the leaves called guard cells, and it lets the air out of the guard cells, and the water vapor is in the air, of course, and then it goes up to the clouds. So those are the two biological things, transpiration and respiration. And this thing happens over and over and over. It might even skip. It might go from condensation, start to fall as precipitation, but never reach the ground and skip the whole runoff or groundwater thing. It may just fall and be evaporated back up before it ever hits the ground. So it doesn't have to go exactly in a circle, but ultimately this whole thing goes in a circle like this. Okay, do you have any questions? Well, no one has their hand up, so I'm going to assume everybody understands nutrient cycles so far. There'll be one more video talking about carbon and talking about nitrogen, but if you have questions, please ask me tomorrow. All right, good to see you. Take care.